Hi there. In this video, we will learn about the dynamic production function, which is a time-explained production function, unlike the static production functions. We will consider the role of time in the current production function. If you are new to this channel, you can subscribe to this channel. You can also click the bell icon so that you continuously receive the material of this kind, which is quantitative and rare in nature. So let's come to the topic, and that is about the output, which depends upon capital, labor, and time. Small t is being used to represent time, and we know that time has the tendency to bring about the technological changes because inventions and innovations, they take place over time due to research and development. And they can bring a shift in the production function outwards. They can favorably shift the production function because of the more favorable technology and hence more output. Now this output is now also a function of time, and this is why we can call it a dynamic production function, because anything that changes over time is considered to be dynamic. And also over time, we know that capital can also become a better form of it, that is, it can become a better physical capital. So we can represent it with K as a function of T. And over time, again, labor can be improved in terms of its quality, and it can become human capital. So labor over time will be improved. So you see, capital and labor both are also now considered to be variable over time. So this output is a function of capital, labor, and time. And now we can say that capital is also dependent upon time and labor as well. So instead of writing simple capital and labor, we have written them in terms of time. Now finally, we want to know that how the output will change over time, that is the phenomenon of dynamic production function. So we use the total derivative because we know a number of derivatives are involved in this process, or a number of rates of change. So primarily we write the left hand side, which is the total derivative. As we can see, d is used, and the effect of t on output is to be calculated. And for that, we see the effect of capital on output as a partial derivative, because now we have capital and labor and time, three independent variables on the right hand side. So once we have more than one independent variables, we use the partial derivatives. In addition to that, we have the effect of time on capital, which will be assessed in this function. Since there is only one independent variable, that is t, this is why we use the simple derivative and not the partial derivative. So the effect of time on capital and the effect of capital on output. In the same way, we can build an expression, that is by using the chain rule of differentiation for labor. Here you can see similar thing is being done, but in this case, capital is what we have as the auxiliary variable. And finally, we have the role of time, so the effect of time on output. So you see, first term was for this, and the second term was for this, and the final term is for this. And we can separate these terms with the help of plus. Now we have tried to elaborate it even further. Partial derivatives, they were put in boxes. As you can see, they are put in boxes to differentiate them from the ordinary derivatives. Now you can pause the video and see that how each of the terms is explained, because here the effect of time on output is observed. And we are writing them in this notation, which is more concise, that is qt, the derivative of q with respect to t. Here the effect of time on labor, effect of time on labor. Here we are using this notation ql and the effect of labor on output. And instead of this term, we are writing k bar t, and again we can see that the effect of time on capital. This is the partial derivative, so it's better to write it like this, k, q, and k in the subscript. And this is the effect of capital on output. So all of the effects on the right hand side, they have been explained. Here we have time, which is affecting the capital and labor, and finally it affects the output. So this is the total derivative that we want to evaluate. After explaining each term in this expression, we can now see that the effect of time on output via labor and capital can be found by using this total derivative term. This is an example that will help us to elaborate. This is the production function that we're dealing with. It's a dynamic production function because we have time as one of the independent variables. AT is showing the technology which is likely to increase over time, because A is showing the contribution of other factors than capital and labor, and time is determining it, that is the technology. Capital function is further elaborated because we know that time can affect capital as well. One part of it will be the autonomous part, which doesn't depend on time, and the other part is dependent upon time, that is A into T. T is time and A is the coefficient that determines that how time will affect the capital. So this is the autonomous part and this is the induced part. This is known as the initial condition of K, that is K naught, and this is the time-induced improvement in capital. This is labor function, and it is quite synonymous to what we have seen above, the initial level of labor and the other part, that is the induced part. So again, we have similar notations. From general form of dynamic production function, this is the general form that we have seen above, and now we want to substitute the values by finding them first. So I have to find out Qt, I have to find out this term, this term, this term. All of these terms are basically the derivative terms. So now we have written them in a more simplified form because we want to focus on what is required. These are the 5 terms that are required. They are on the right hand side. So we are going to find them one by one. The very first term in the box, for that simply we need to take the derivative, the partial derivative of the output function with respect to k. So this is the output function and this is the answer once we take its partial derivative. Similar to that is this term, so I can try to focus on this term by jumping over this term. This term is again similar because we are taking the partial derivative, and it's the same production function. This is the derivative after the calculations. And again, a partial derivative with respect to time. So here, instead of capital or labor, I'm using time. So the same production function and its derivative with respect to time. In this case, you can see this term is affected because it is explicitly explained in terms of time. Whereas here, capital was affected, power was applied, and here labor was affected as power was applied on labor. These are the 2 terms that require a simple derivative, not the partial derivative. So capital function with respect to time, here we are, capital function with respect to time. So we take the derivative of it and we have A as the answer of it, and we have B as the answer of this function, that is the derivative of labor function with respect to time. So now we have all the values that we need and we can put them on the right hand side. So writing the formula one more time and substituting the values in the boxes, we can see the answers of the partial derivatives. Here we are, and here we have the values of the ordinary derivatives A and B. Now we are going to simplify this. We can see a power of -1, but it's better to reciprocalize it and bring it in the denominator. Once we did this, we can see that there is a couple of terms that is common, that is capital alpha and labor beta. It is present here as well and here as well. So what we do is we take it as a common factor, and remaining terms, they appear as they are. They are still in the boxes just to make it more readable. And now we can remove these boxes and write the final answer. So what you see is that the dynamics of the production function with time-dependent capital and labor is formulated here, because now the time is determining capital and labor, and finally the output. So in this way, the dynamic production function can be understood and can also be understood with the help of an example. This is dynamic because we can see that all of the variables, especially the output variable, is getting affected due to time. I hope you have learned from this video, and if you have, then you may like this video. Thank you.